Hi, I'm Anesha from IBM. In this video, I will show you how to create a model with Watson Studio. So let's go back to the problem discussed in previous videos. Can we predict heart failure using data? If we are given data with factors such as BPM, BMI, and the result, whether the heart has failed or not, we can build a model using structured machine learning to predict, given the inputs, whether the heart has failed or not. How will we build a model? We can easily do this in Watson Studio. So this video is assuming you have already created a Watson Studio project and imported data from a CSV file that contains a table with different health factors and whether the heart has failed or not. If you haven't done this step, please check out the previous video. Let's go back to the Watson Studio homepage. Let's go to My Projects and open up our project. In this project, we have added an instance of Watson Machine Learning, which is what will do the structured machine learning needed to create our model. When we click Assets, we can see our CSV file that has our data. If you want, you can click to see the data and refine it with Data Refinery. Going back to this asset page, we can see the section called Models. Let's click the model, New Watson Machine Learning Model. Enter a name and description for your model. We can select which machine learning service we want to use, if you have multiple. Since we have already created one, it should automatically be selected. You have the option to select a model from a file or sample, but in this example, we will be showing the model builder, so model builder is selected. We have two options here, manual or automatic. With automatic, you do not have the option to select evaluators, which are the machine learning algorithms such as SVM or linear regression. Instead, the best evaluator will automatically be selected based on the characteristics of the training data. With manual, we will have the option to select evaluators. If you want something more specific, you can create a notebook or design a modeler flow instead of doing this. Select the default Spark runtime and click Create. Now we select the data asset and wait. Now we are in the Train tab and we have the ability to train our model. That means we are building and evaluating our model. In this tab, we select which column value we want to predict. Since we want to predict heart failure, we will select that from the Select Label column tab. Now we can select which features we want to use to train the model. By default, all are selected, but you can remove features if you want. Since we are predicting heart failure, which is either true or false, it has two distinct categories. So, we will pick binary classification, as that is the appropriate option for classifications when we have two distinct categories. With the slider, we can select how much of our data we allocate for training, which is the subsection of the data set that the algorithm learns from, testing, the subsection that we validate the algorithm with, and holdout, which is what we use as the final estimation of the model's performance. For this example, we will leave the default values. On the right side, we can select what evaluators we want to use, as we are using the manual option. We can select logistic regression, decision tree classifier, gradient boosted tree classifier, and random forest classifier. Let's select all of them. Now we are taken to the Evaluate tab. This will take some time depending on how many resources you have allocated or how much data you are importing. As you can see, we have created 4 different machine learning algorithms, each with a different algorithm. We can see the performance of each as indicated by the status, performance, area under curve. Some of them are trained better than others, as you can see some failures here. Now we select the best one to keep as our model, and we click Save to save our model. In this example, I'll select Random Forest Classifier, as it has the best performance of the four. We click Save to save our model. Now that we have trained our model, we will move on to deployment. What this means is we will be taking the model we just built and packaging it, fronting it within Web API, and deploying it as a new service. We need to do this to access our model and test it out. The deployed model will be fronted by a public API, and after deployment, code is automatically generated for you, showing you how to invoke the model. Go to the Deployments tab and click Add Deployment. Enter a name and description for this deployment. Now that the deployment is complete, we can click underneath Actions to view it. We can see the Overview tab, the Implementation tab that has the endpoint, and the Test tab. Let's try this out. Let's enter some data in the Test tab, and we can get a prediction based on our model whether the heart will fail or not. This is just some fake data I'm entering, I'm just making it up. With our model, we should be able to predict whether someone with this fake data would have a heart that fails or not. After entering some sample data, we can see, no, this input will not fail based on our model. So there you have it. Without any programming at all, you have created and deployed a model that can be used to predict heart rate failure.